Right, so this is the first one, right? These are the answers to the first one, right? So what about the -2 limit question? Yes, -2 is the answer. So I will do the. Shall I do the question? Don't. Question number 6. Yes, let's do that question. Question number 6 today. So the -2 is the answer for question number 5. Question. Make a correction mark here. The answer is but the answer is final answer is incorrect. That is minus infinity up to -2 and correct that one. Right. So with the question number 6 right, let's see question number 6. Now question number 6 is based from what? The region enclosed by the curves y is equal to x, x is equal 1, x is equal 2 is the rotated about the x-axis through 2 pi radius. Determine the volume of the solid generated. Okay, right. First of all, we need to sketch a small graph. So can you remember the graph of y is equal ln x? So what is the graph now? So just like this, right? So can you tell me what is this point? That is 1. Okay. So we need the area enclosed by the curves x is equal 1. That means this point, and x is equal 2 mean this one. So we need to find out the area. This one. That is S1. Okay. So what is the formula? S is equal to, that is y dx. Y dx. So this is the formula. This area is rotated around the x-axis. Right? We need to find the volume here. Right. So if the volume is V, how can we find the volume? That is A to B 5 y squared dx. Okay. So I'm going to apply the A to B mean 1 to 2 5 y squared. Now y is equal ln x. Y is equal ln x. That means ln x whole squared into dx. Okay, right. You can take out this 5 out. So 5 into 1 to 2 ln x whole squared dx. So how can we integrate ln x whole squared? Ln x whole square. We have done that question in theory class using integration by parts. Oh yes, multiplied by 1, integration by parts method. Okay. Right. So here I'm going to put a 1 here dx. Now 5 into 1 to 2 ln x whole squared. When you integrate 1, my answer is d over dx, x dx. Right. So that means 5 into x into ln x whole square. You need to apply the limit 1 to 2 minus 1 to 2 again. X into, when you differentiate ln x whole square, that will be 2 into ln x. When you differentiate ln x, it will be 1 over x dx. You can cancel out x and x. So 5 here, when you apply the 2 into ln 2 whole square. When you apply 1 to the ln 1, 0. Right. Now minus you can take out 2, 1 to 2 again, ln x dx. Again, you need to apply the integration by parts method again. Okay? So that's a very long question. Right. So here, what is the answer? 2, 5 ln 2 whole square minus 2 into, again here 1 to 2 ln x d over dx x dx. So 2, 5 ln 2 whole square minus 2 into ln x into x. Limit is 1 to 2 minus 1 to 2 x into 1 over x dx. Right. Okay, now the final answer. 2, 5 ln 2 whole square minus 2 into, when you apply 2 into ln 2, 1, 0, that is minus. When you integrate a1, it will be x. Limit is 1 to 2. Between 2 minus 1, that will be 1. Right. Right. So 2, 5 ln 2 whole square minus 4 into ln 2 positive 2 minus. That will be positive 2. Minus positive 2. So this will be the answer. I'm not going to simplify it for the. So just like that, we can leave the answer. It's a very ugly answer. We need to use the integration by parts method twice here. First of all here, then after that we need to integrate the lnx as well. So like that we can find the volume of this generated object. So the answer is ugly, Hari. Don't think about the answer. ln2 whole square, right? So that is question number 6, Lamai. So that is the answer. Got some kind of ugly answer, right? So what about question number 7, Lamai? We need to find that area, right? So have we got the answer? Area. Okay, let's do this question. Now we need a system. Right. So question number 7, Lamai. So applications of derivatives. C curve is given by x is equal to t, Lamai. That means dx over dt, Lamai. That is equal to 2. Right. Then y is equal to t squared, Lamai. So dy by dt, Lamai. That is equal to 2t. Now using these two, Lamai, we can find the dy by dx. Okay. So using the chain rule, dy by dx, that is equal dy by dt over dx. So dy by dt mean, Lamai, that is 2t. Here 1 over dx by dt, that means 2. So the answer will be t. Okay. Now we need to find the gradient of the tangent, Lamai, at p point. So at p point t is equal to 3, Lamai. Right. Find the equation of the vertical which is drawn at p, Lamai. That's the normal. Right. So first of all, let's find out the gradient of the tangent. Gradient of the tangent. So that is equal dy by dx, Lamai. The t value is given. T is equal 3, Lamai. Right. So that means what? Just 3, easy. Right. So the gradient of the normal. Gradient of the normal. That is equal what? Minus 1/3. Right. Now over there we can find the equation of the normal. Equation of the normal. So to find the equation for there, we need to find the coordinates of this p point. Right. So what are the coordinates for there? When t is equal to 3, Lamai, x coordinate is 2 into 3. That means 6. Y coordinate is 3 square. That means 9. So now I can write down the equation for this. So y minus y naught. That means 9. That is equal gradient. Minus 1/3 into x minus x naught. That will be 6, Lamai. So I'm going to multiply it by 3, Lamai. So 3y minus 27 minus 6 positive 6. So 3y positive x, Lamai, minus 33 is equal to 0. This is the equation of the normal. Now what? This vertical, this normal meet the y-axis at point B, Lamai. Find the area R enclosed by the lines OB, BP and OP, Lamai. Right, let's see. Now imagine this is the OXY plane. Okay, right. So this is the normal. You can see the gradient is what? That means 3y is equal minus x positive 33. So y is equal minus 130 into x positive 11 now. So if you draw the line, it will be minus, that means the negative gradient and positive y-intercept. It will be just like that. This is 11. So y-axis, origin and the x-axis for the right. So this vertical meet the y-axis at the point B, Lamai. So this is point B, Lamai. This is O. Find the area on OB, BP. OB, BP, and OP. What is the P point? Coordinates of the P point for 6 and 9. Right. Now this point is on this line. This is the P point for 6 and 9. Now this point lies on this straight line. Now we need to find the area of this OBP triangle. That means this one. OPB triangle. This one. How can we find the area? That means the base and the height. Right. So tell me. Now we can see the base is what? 11. So what is the height here? Height that means the x coordinate. X coordinate 6. So here it will be 6. Right? So area of OBP triangle. But that is equal half into 11 into this will be 6. So that is what? 33 squared units. So that is the area of the OPB triangle. Right. That is 33 squared units. Right. Let's do question number 10. Question number 10. Let's do question number 10 after that. Right. So that is a theorem. Let's see. Question number 10. Right. Question number 10. Right, in question number 10, it says that when ABC are real constants, they show that if this happens, but the equation A sin is B cos x is equal to C has got real solutions. Right. So this is question number 10. So this is the equation for A sin x, B cos x is equal to C. Okay, now tell me, how can we solve this kind of equations? We need to divide and multiply it by square root of A square plus B square. So I'm going to divide this by square root of A square plus B square because we got two sides. So A over root A squared plus B squared sin x and B over root A squared plus B squared cos x, and that is equal C over root A squared plus B squared. Okay, right. Now, we can take these as sin no cos my result method. So I'm going to take let cos alpha is equal A over root A squared plus B squared. That means my sin alpha will equal to B over root A squared plus B squared. Right. That means the cos alpha sin x and sin alpha cos x is equal to C over root A squared plus B squared. Now here A plus B formula, sin cos cos sin. That means sin x plus alpha. That is equal C over root A squared plus B squared. Right. Now, from this one, we know that if x is real, now the sign is real, we know that the value should be taken in between -1 and +1. So that is the interval of sign. What is the minimum value? -1. Maximum value? +1. So we can get that inequality from that one. Right? So I'm going to write down since sin x plus alpha greater than or equal -1 but less than or equal +1. Right? Now we know that this is equal to this one. So -1 C over root A squared plus B squared less than or equal 1. So we only have to consider about this part. Let's consider about this part. So C over root A squared plus B squared is less than or equal 1. Right. So C less than or equal root A squared plus B squared. Now here I multiplied both sides by root A squared plus B squared because that is positive. This is the main square root of this one. So this is positive, correct? So we can multiply it by just like that. Okay. So when you square it, c squared is less than or equal what? A square plus b square. Okay. So if this inequality is true, lamai, we can say that we can find a real value for x lamai. That's it. So that is question number 10 lamai. So you can do these 5 questions. 1, 2, 3, 4, and 5. Next week, you will be able to do the binomial expansion question as well. So next week you can do 6 questions per day. 6 and next week with the we can do the series lesson as well. Next period with it, there are 2 weeks. Then you can do 6 questions from part tail and 4.5 questions. 1, 2, 3, 4, yes, 4.5 questions. You can do the series question as well. Is that too long? 16. 16. Where? 60. Okay, finished. Okay, yes. I'm going to do the quadratic equation question and after the polynomial question. All right. So I will erase this one. Right. Now the polynomial and the quadratic equation question. Okay. Question number 11 for the part A. Alpha and beta are the root of the quadratic equation x squared px plus q is equal 0 lamai. And gamma and delta are the roots of this one today. X squared rx s is equal 0. So the roots are gamma and delta. Here the roots are lamai, alpha and beta. Okay, now what next? Find the value of alpha minus gamma. So alpha minus gamma, alpha minus delta, beta minus gamma, beta minus delta lamai. Right. Let's do the simplification. I'm going to multiply these two and these two numbers. Okay. So here alpha is squared. Then alpha delta minus gamma alpha positive gamma delta. Then with the beta squared minus beta delta gamma beta and positive gamma delta. Right. So here with the alpha squared you can take out minus alpha. So gamma plus delta gamma delta. And beta squared minus beta, that means delta plus gamma and again gamma delta. Right. So alpha squared minus alpha into what is gamma plus delta? Gamma plus delta means that should be minus r. That is minus r. Gamma delta is right. Beta squared minus beta, then again gamma plus delta. That means minus r again. This minus r. Gamma delta mean again s. That is s now. Right. So we got alpha squared positive alpha gamma s. Then with a beta squared positive beta gamma positive s lamai. Right. Still we can't do anything about this one. Again we need to do the simplification with it. Alpha squared. Can't do that. Right. So let's do the simplification. So alpha squared into beta squared will be alpha squared beta squared. Then beta alpha squared gamma. Then alpha squared s. Alpha beta squared gamma. Then alpha beta gamma squared. Then alpha gamma s. Right. One more step lamai. S beta squared, S beta gamma, and S squared lamai. Right. Again, alpha beta whole square mean alpha beta mean q. So q squared. Right. Now let's try to take out the common terms here now. Beta alpha squared gamma. Beta alpha squared. Now there you can see beta alpha squared gamma and alpha beta squared gamma. Now using these two lamai, we can take out alpha beta. Alpha beta gamma. So it will be alpha plus beta. Right. Okay. So alpha squared is lamai and s beta squared. We can take out s. So alpha squared plus beta squared. Okay. Right. So what next? Alpha beta gamma squared. Alpha beta mean again q. So here q gamma squared. The gamma squared as well. Then what? Alpha, beta, gamma is correct. S beta is squared, S beta, gamma. Can we take out S? S alpha is squared and S beta we have taken that, right? So S beta gamma. Beta gamma means beta gamma. No, we don't know beta gamma, but S is here. Beta gamma, beta gamma, beta gamma, beta gamma. Beta gamma, beta gamma. Or මොකක් term එකක් මිස් වෙනවද? S alpha squared x alpha gamma s alpha gamma s alpha gamma s where's alpha gamma s this alpha gamma s ne alpha gamma s පුතේ අපි ගත්තද alpha gamma s no ne we haven't taken the alpha gamma s ne මේ ගත්තේ නැහැ නේද so we can take these two we can take out gamma s right that means alpha plus beta and finally s squared. Right, let's check the final answer. So Q is squared lamai. Alpha beta. Alpha beta mean lamai what? Alpha beta mean minus P. So minus P again gamma into alpha plus beta. It should be you are and show. Alpha plus beta. Minus P. Yeah, alpha beta mean Q, ne? It should be Q. So S alpha squared plus B alpha plus beta whole square mean for the P square minus 2 alpha beta mean there is Q ne? Minus 2Q. Here Q R square ne? Here is R square. Now correct me, it's not the gamma square, R square. This one is R square. Again R is into alpha plus beta. Alpha plus beta mean for the again minus 2. And S square. Ayyo, these roots are very ugly, gamma and gamma. That is so. So Q is squared minus PQR. Then SP squared minus 2SQ. And QR is squared minus PSR plus SR. May can't we simplify this one? Easy answer. Very long one. Ayyo. So is that it? Is the answer. Q squared minus PQR. SP squared minus 2SQ. QR squared minus PSR plus S squared. Is that? Oh, wow. We can't simplify it, ne? And now we can. This is Q minus S whole square. Now here we can just simplify it as per this is Q minus S whole square. That means Q is squared minus 2SQ and S squared. Okay. Right. So what about the other two terms? Is there a common term, Lamai? Minus PQR, SP squared, QR squared. You can take out R, ne? But there's SP squared there. Oh, it's very ugly, Annie. No. Can minus PQR minus PSR. You can take out minus PR, ne? And that will QS. And here again you can take out. No. You consider these two, Lamai. Can we take out P squared, ne? No, we can take out P. So SP minus. So when you consider these two, Lamai, we can take out R again, ne? So QR minus PS, QR minus PS. I think we can take out one P from here. So it will be when you take out P lamma, PS minus QR. And here again, Pute, I'm going to take out R. So again, QR minus PS. Right. Now that means Q minus S whole square. I'm going to take out a minus sign now. Minus P QR minus PS. Again, put a positive R into QR minus PS. Now Q minus S whole squared, you can take out QR minus PS out. So it will be my R minus P. Like that. We can simplify it up to this point. Put a Q minus S whole squared, Q minus PS, R minus P. That is somewhat beautiful compared to this one. Okay, right. You can show that Q na hari. Anyway, what's the next one? They deduce the requirement to has a common root. So what is the requirement? If it has a common root, what is the requirement? Yeah, we can guess that. Now, if there's a common root for these two, what can you tell about the roots? Now, alpha, beta, and gamma, delta. If there's a common root, alpha should be equal to gamma or delta, or beta should be equal to gamma or delta. Then there is a common root. What happened if alpha is equal to gamma or delta? What can you tell about here? Now, imagine alpha is equal to gamma, so this part will be 0. That means the whole part will be 0. If alpha is equal to delta, again, this will be 0. Beta is equal to gamma, this will be. Beta is equal to delta. So anyhow, if there's a common root, this LHS side become 0. Okay, so let's write down that one. Then we can get that some kind of a mathematical expression. Right, so I'm going to write down. But if there's a common root, if there is a common root, that means I'm not going to write down all the things now. My LHS sign is equal to 0. Okay, that means Q minus X whole square plus Q minus PS, then R minus P will equal to 0. So I think that's it. We can stop the question from here. So that is the mathematical requirement. If there's a common root, Q minus S whole squared is equal to Q minus S square is equal to P minus R, Q minus PS, something like this. So we can get this kind of a relationship between P, Q, R, and S. Q minus S whole squared is equal P minus R into Q minus P S. That's it. So that is beautiful. This requirement is beautiful. So when you take this R minus P, it will be P minus R. Right. So that's it. Okay, let's go to the question number 2 after that. Now, from this point onwards, they are essentially gamma. So here there's the gamma, but from this point onwards, they are essentially gamma. Only R is there. So I just surprised by I got the answer. R and gamma is present. Right. Okay, right. So anyhow, like that, we can do that quadratic equation question. I think if the answer is given, the question is more beautiful. Show that obtain this answer. Answer is great, right? So let's go to the second part of the quadratic equation question. Okay, let's go to the second part. So I'll erase this one. Let's go to the second part, Lamai. Find the values of M Lamai such that X is real for all real values of X Lamai. So first of all, the second part, let Y is equal to 2x squared minus 5x positive 3 over 4x minus M Lamai. Find the values of M such that X is real for real values of X Lamai. First of all, I'm going to rewrite this as a quadratic equation of X Lamai. Then let's see if X is real, what will happen. Okay? So here Lamai 4xy minus my. So 2x squared minus 5x positive 3. Okay. That means 2x squared minus 5x minus 4xy positive 3 positive my is equal 0. 2x squared, you can take out minus x, 5 plus 4y, positive 3, positive my is equal 0. Now, this is a quadratic equation of x number. So, if x is real number, delta is greater than or equal 0. Okay, right. So, if x is real, that means delta x is greater than or equal 0. So, what is delta x? B squared minus 4ac greater than or equal 0. What is b squared number? That means 5 plus 4y, negative 5 plus 4y whole square, so it will be positive. Minus 4a mean 2, c mean lamai 3 plus my. So that is greater than or equal 0, right? So 25, 16y squared, 40 into y, minus 24, and with a minus 8my greater than or equal 0, right? So 16y squared, 16y squared. Then you can take out, if you consider these two lemma, you can take out 8y. So it will be lemma what? 5 minus m. Okay, and finally lemma 25 minus 24 mean 1. That is equals, that is equal greater than equals. So we can come up to this point now. Okay, so if x is real lemma, we can come up to this point. Now what we need lemma? Find the values of m such that x is real. Right. Okay, now what can we do, Lam? Now again, Putty, you can see we got another quadratic equation of y Lamai. Right? So we need to find out the m values Lamai such that this quadratic expression or this quadratic function is what, Putty? Positive. Now this time you can see this another quadratic function. Now this quadratic function should be what, Putty? Positive. Make a positive end node. If a quadratic function is positive Lamai, what are the requirements? Let f of x is equal ax squared bx plus c lamai. This is a quadratic function now. If this quadratic function is positive for all real values of x lamai, what is the requirement? Discriminant should be less than 0. Good, second. Can you remember the graph lamai? If it is positive lamai, this should be the graph lamai. Graph again. Graph you can see now delta is what? Negative. Okay, A is positive. A positive you can see now A is positive here. Delta should be what today now? Negative. Correct. It's a very beautiful question. So here I'm going to write down today. Now, if the function is positive, we can say that today delta is less than or equal 0. Why I got the 0 value? Because it can touch the x-axis as well. Because this time you can see greater than or equal 0. So this time the graph can touch the x-axis as well. So when the graph touches the x-axis, what will happen? Delta is now 0. So delta is 0 or it should be negative. So here I'm going to write down the delta again. So delta mean again what? B squared minus 4c. So what is the b value here? 8 into 5 minus m whole square. Minus 4a means 16. This is 1 today. This is less than or equal 0. So 64, 5 minus m whole square today minus 64 less than or equal 0. So 64 and 64 will cancel out. 5 minus m whole square minus 1 square is less than or equal 0. So we can factorize it today. 5 minus m minus 1, 5 minus m positive 1 less than or equal 0. So 4 minus m and with a 6 minus m less than or equal 0. Right. So we can draw a number line here. So what are the relevant two values for the 4 and 6? 4 and 6. We need to take these 2 points. Imagine any value greater than 6, 7 vageda. Negative, negative, positive. So negative, positive. We need the negative interval. So what is the m values now? That means 4 to 6 close brackets. So this is the relevant m values. You can see that's a very beautiful question. It's a very complex question. So when if x is real number, we can come up to this point. Now this is a quadratic function again. Now this quadratic function should be what? Positive. If this quadratic function is positive, what can you do about the discriminant? Negative. It's a very complex question. If this function is positive, delta should be negative. With delta negative, we can find out the relevant m values. So that is the way to do this question. Okay, right. So that is quadratic equation part 2. Right. Now let's do the polynomial question as well. Okay? Let's do the polynomial question after that. Right, let's go to the part B. Ne? Right, part B. Right. So this is part B la my polynomial question. Polynomial one. F of x is a polynomial and k is a constant, but f of x is given to us. When f of x is divided by x minus 1, remainder is r. When it is divided by x minus 4, remainder is 8. Find k and r now. Okay, let's see. So when f of x is divided by lamai x minus 1, when f of x is divided by x minus 1, what is the remainder lamai? F of 1, that is equal to lamai r, ne? That is equal r. That means k minus 1 plus 12 is equal r. That means k plus 11 is equal r. This is the number 1. Okay. Next one is when f of x is divided by what? X minus 4 lamai, ne? So the remainder is f of 4 lamai. That is equal to 8 r. So what is f of 4 lamai? That means 16k minus 4 positive 12, that is equal 8 r. So 16k 8 is equal 8 r. You can divide this by 8 lamai. So 2k plus 1 is equal r lamai. Okay. So that means this is the second equation. We can equate these 1 and 2 now. We can equate this 1 and 2 lamai, right? That means k plus 11 is equal to 2k plus 1. That means k is equal to 10. K is equal 10 means r is equal 21. So these are the values of k and r. Okay, right. Right. Find k and r. Show that x plus 4 is a factor of f of x lamai. Right. Now lamai, f of x is equal to kx squared. That means 10x squared minus x positive 12. So when x is equal minus 4, f of minus 4 lamai. 10 into minus 4 squared minus into minus 4 positive 12. So that will be what? 116. Eh? We can't show that x plus 4 is a factor. No, ne? Oh. So that is not a factor, ne, lamai. What about for the minus 1 again? No, ne? Plus 1, no. What about positive? Positive for them doesn't matter. You got a very big value, ne? 2 them 40. No. Factors of this one, ne? Ayyo. X plus 4 is a factor. Half them 10 over 4 minus half. 10 by 4 minus 2 by 4. 8 by 4. 2 and 12 and 3. No. We can't find a factor. X plus 4. Jika factor එකක්වත් guess කරන්න බෑ. Can we guess any factor? No නේ. එකක්වත් guess කරන්න බෑනේ. අයියෝ වැඩක් නැහැ. 1/3. 10 over 9 minus 1/3 plus 12. So 10 minus 3 over 9. 7 by 9. Again වැඩක් නැහැ. Sorry about that one. So if we can find a factor, then we need to show that there is only one real root for f. How can you do that? Imagine x plus 4 is a factor. So how can you do the other part? We need to use the long division method. Do the long division method, then you will get a quadratic equation as a quotient. You need to tell that delta is negative for that part. Then there's only one factor. There is that one. So here, Maybe we can leave it like that. Okay, so can't get the part. Okay. Okay, so that is the method. Okay, so keep in mind we can't solve that. Right. So what about the graph? I think graph has done. Yeah, we've done the graph. What about the second part? For the part B, I've got the answer x is equal 3/2. 6/2. 3/2. Just do that question from the right. So I will do the question from this part today. So I think all of you can get this part. L is equal root x squared plus 3 squared positive root 4 minus x squared 5 squared. I think you can get this part. Make our name. Okay, you can get this part. Okay, right. Now we can differentiate it with respect to x. Right. So by differentiating. So dl over dx. So here 1 over 2 into root x squared plus 3 squared, and here it will be 2x. Right. So 1 over root 4 minus 6 whole squared plus 5 squared. But then again you need to differentiate this one. So it will be 2 into 4 minus x and minus 1. So just like that we can do the differentiation part. Right. So 2 and 2 will cancel out today. Right. Here again there's a 2. So 2 and 2 will cancel out. Right. Now when dl over dx is equal to 0. Right. That means x over root x squared plus 9. Here positive x minus 4 over root 4 minus 6 whole squared positive 25. That is equal to 0. Now we need to simplify this one. No other option here again. Right. So let's do a cross multiplication today. So x over root x squared plus 9. That is equal to 4 minus x. When you take that here, 4 minus 6 over. When you simplify this one, what is the answer? Let's do that later. 4 minus 6 whole squared positive 25. Okay, now squared it. So x squared over x squared plus 9. Here 4 minus 6 whole squared over 4 minus 6 whole squared 25. Quite very difficult. These questions. Right. So x squared into 4 minus 6 whole squared 25 x squared. Here x squared into 4 minus 6 whole squared. Then 9 into 4 minus 6 whole squared. Right. Hoppa. So very difficult. I thought this was a very easy question. This part is easy. Get this part. Right. So I'll erase this part. Right. So we need to. Can we cancel? Can't do anything. We can take this one over here. We can cancel out this part. Yes, that is easy now. I thought that was difficult. No, it is easy. So 25 x squared, that is equal what? That is equal what for the 9 into 4 minus 6 whole square, right? So that is 5x whole square per day minus this into 4 minus 6 whole square. Right. So that is equal to 0. You can factorize it with 4x minus 3 into 4 means minus 12. Minus 12 positive 3x. Next one is the 5x positive 12 minus 3x. Right, that is equal to 0. So 8x minus 12. And the next one is for the 2x positive 12 is equal to 0. So we got two values. 8x minus 12 is equal to 0. Or 2x plus 12 is equal to 0. Now we know that this can't be true. What is the reason? Because it should be greater than 0. We can't take a negative value. So that means 8x is equal to 12. So when you divide it by 4, 3 by 2. So we can get the answer. 3 by 2. Can get that answer. Finally, you need to say that when x is equal 3 by 2, there should be 0. Here, the sign of the sign of what? dl by dx. We should have the maximum, minimum. So negative to positive. So that is minimum. So when x is equal 3